Good morning, everyone. Today I'm going to share with you a very interesting topic, and it is interesting because it's related to our aging and its variety. This topic is identity noise and adipogenic traits characterize dermal fibroblast aging, which published in the Cell. His paper was published by the IRB Research Center in Spain. And IIB Barcelona is a world-class research center devoted to understanding fundamental questions about human health and disease. The corresponding author is Professor Salvador, global leader of tumor research of the IIB Research Center. So IIB global aim is to characterize the molecular pathway that regulate the behavior of normal stem cells during homeostasis and how they become deregulated during carcinogenesis and aging. Introduction. Let's take a brief look at what is the main problem of his paper. Obviously, it is about skin aging. What's the question with skin aging, or the main cause of skin aging? This is because of there is something wrong with dermal fibroblast. So what's going on in fibroblast? The answer is identity noise and adipogenic traits. When we see whether a person is old, usually the first glance is from a person's appearance to decide. For example, an old man's skin is definitely different from the baby's skin. However, it seems that his is not so true, because the last molecular research has found that the old skin is actually similar to the baby skin with abundant fat cells, which may be one of the reasons why the old people look a little fat. But why? Skin's identity crisis. It was never through before that as we age. Our ability to regenerate tissue after injury is affected to very degrees. Fibroblasts lose their cellular identity and they forget who they are. Therefore, change in cell activity can affect the state of skin tissue. His study shows the cellular and molecular pathway affected by aging and suggests how to manipulate them to delay or even reverse skin aging. We can observe the changes of dermal fibroblast aging in his figure. From young to old, identity noise and adipogenic traits and immunity will increase. Collagen and protein explorer and oxidative phosphorylation will decline. As we see, his red, blue, and other different fibroblasts on aging skin is relatively much less. The density of the dermis will decrease, and the fat cells in numbers below will increase. There are the characteristics of aging skin, but it can be changed through the diet plan. As it says, calorie restriction can reverse the skin aging, and heavy diet will be accelerate aging. We found that the older fibroblasts seem to have forgotten who they are. It's not only reduced the expression of collagen and other ECM-related genes and paradoxically, it's become more like pro-adipogenic fibroblast in the newborn skin. It do the work of adipose cell. As a result, skin aging symptoms occur. So the skin change from young to old can be seen in Figure 1a. First, the thickness of dermis and the density of ECM will decrease with the increase of age, which is the decline of stromal cell function. Second, the subdermis is gradually thickening, which seems to generate generate pro-adipogenic phenomena. However, his change have been initiated since the Middle Age. The reason from his change is that Fibroblast has forgotten its identity and thus forgotten what it should be doing. Therefore, the purpose of his experiment is to confirm the following things. Number one, why did all the dermal fibroblasts have an identity undefined and noise problem? Number two, why is all the dermal fibroblasts prone to adipogenic traits? Number three, does different dietary plans change the problem of fibroblast aging? Number four, does identity loss of fibroblasts contribute to the development of aging? Method. Because his study used a lot of gene information and biostatistics on the basis of animal experiment, it is a little complicated. I can only briefly say that the method of his experiment is mainly divided into three parts. The first is that animal model were designed to include comparison between newborn, young and old mice, and of course mice with specific genetic mutation were used to observe change in fibroblasts in the offspring of hybrids. The second part is the detail of the experiment method. The most important, of course, is the culture of fibroblasts and then a bunch of immunofluorescence staining. The third part is quantification and statistical analysis, mainly a quantification of skin morphology features, microarray and RNA sequence, and PCA. So this is the first time for me to have access to so many papers of biological information and statistics.